Perfect. So I wanted to start this off. I think a lot of you are aware, but let's talk a little bit about Flagsmith, and then I will stop talking and we'll jump into the fun stuff. But Flagsmith is an open source feature management platform that enables enterprises to decouple deployment from release, letting teams ship continuously, roll out gradually, and recover instantly. So we have enterprise governance, auditability, and open source transparency so that engineering and product teams can experiment safely, validate ideas faster, and build better products without slowing innovation or compromising compliance. Okay, so what are we going through today? First of all, the feature flag paradox. So, how success can actually lead to operational debt and unmanaged life cycles. We'll quantify the risk for you, so understand what that true cost of technical debt can look like, and then provide a three-question approach to audit and stabilize your current flag environment and a bit of a life cycle framework. We're also going to go into automated governance, so how leveraging MCP servers can actually replace some of this really painful manual maintenance, and then go into some real world demonstrations, a little bit around that optimal control level for what you're comfortable with in terms of automation versus human in the loop. And then we'll jump into a Q&A. So please feel free to pop your questions in throughout the presentation as they come, and we'll go through those at the end. And yeah, I'll also be sharing the recording and the slide set with everybody as well, so that you'll have this to share with folks on your team who may not have been able to make it. And with that, I will let Asaf jump in. Take it away. Thank you.
Thank you, Mia. I'll use this audience to also wish you a happy birthday. And thank you for joining us so early in the day on your birthday. Much appreciated.
Thank you.
And let's jump in. Um, as your feature flag program is working, um, you realize that actually that is the problem that you're having. So what I mean by that is that having lots of flags isn't a failure. That's a good sign that your team is adopting feature flag well in the organization. But the problem is actually what comes after that. So we know that as organizations grow and deliver more features, the number of flags continue to grow. And at first, it does not feel like a problem. It doesn't harm anything. It's not technical debt. But as the numbers cross a certain threshold, suddenly this does become a problem. And basically, we become the victims of our own success. I've been there personally. I've seen it happen to multiple customers of ours. And there's a lot of excitement. The adoption goes high. It becomes part of your software delivery lifecycle. And this muscle of feature flagging gets stronger. But comes a moment where this technical debt becomes real. Um, this success creates a technical debt, and at first it's silent and nobody notices it until suddenly somebody does notice it. Suddenly, this backlog of debt starts to grow faster than you can treat it, and everybody's looking at this, and honestly, nobody really knows what to do about it. And a little bit about how it looks. So really, we start the life cycle, in theory at least, is that engineers ship a new flag, ship a new feature, a new version, a new experiment, a new iteration, whatever it is. It gets gradually rolled out. Canary releases, specific segments. That's the power of the flags. We decouple the deployment from the release. And this rollout phase can last a while. It can be hours for small things, it can be days or weeks, and sometimes if it's even longer than that. And then comes a point where it's idle in prod. The rollout is completed, the feature is live. The flag, in essence, doesn't really do anything anymore. It's just always on for 100% of the users of your application. And the next phase, in theory, is to remove it. In practice, that last phase rarely happens. It really does feel like a lot of risk. Many times we're not sure who's the owner of that flag. We're not sure, is it really 100% in production? As the numbers grow, this is where it starts to become more tricky. Maybe we have similarly named flags. Now we're not even sure what each flag really does. Um, and people tend to skip it. It's just not exciting to remove a flag. The risk reward ratio on these kinds of actions is usually not very high. It's never prioritized. And speaking now more as a product person than an engineering person, this requires engineering effort into something that, at least in theory, does not deliver any immediate value. So I've seen multiple times how product people, they just forget about it. They don't see the value in removing flags. This is more common with product people than engineers, but it happens over and over again. So the theory is pretty simple. In practice, what we're doing is basically we're not cleaning our gutters. And as long as it's not raining outside, that's really not a problem. But the moment it starts to rain, we suddenly sit and realize we really should have done that earlier. So that's when things get messy. A little bit about the scale of what we're talking about here, because this is not hypothetical. We've seen this play out across multiple engineering organizations, from big to small. And just a few numbers to put things in perspective. So, an example from Uber is a report they published a few years ago where they admitted to have over 6,000 flags active in a single company. Out of those, 1,300 of them were unused. This problem was actually so big that Uber engineering team had to build a dedicated tool called Piranha that was just built in order to help them to identify the parts in the code that they can actually remove. It was that unmanageable. Another example we can take from Stripe's latest report, over 30% of engineering time is lost to managing technical debt. I'm not claiming all of that debt belongs to feature flagging, but a big chunk of it definitely does. That's basically a third of the engineering time capacity, not building new features. And any small percentage we can cut out of that directly translates to being able to deliver more and faster. And today, especially, 42% of committed code is AI assisted. This number changes almost on a daily basis, and the trajectory is clearly going up. We all see more code getting shipped to production. Every new feature means a new flag. Some of this code is not written at all by a human. Some brave organizations, this code isn't even reviewed by a human. So as we see this increase of AI assisted, AI led, or completely AI written code, we're seeing way more features, way more experiments. The cost of product iteration and experimentation has basically collapsed, and that translates to way quicker turnover times. And that directly translates to more flags that you have in production. Deprioritizing this act of what's called flag hygiene, it feels like a low risk, but as we see these numbers, it really isn't. When your flag program gets bloated, it really hides critical dependencies. It slows down all the engineering teams. And counterintuitively, it actually reintroduces real release risk. So what we implemented at first to reduce the risk of release suddenly becomes the reason why releasing becomes more dangerous. And the question is, where do we really start? If we agree that this is a problem that needs our attention, why, and we agree that it really matters to our organization, to the velocity we can move in, where do we begin? You can see here an example of what the dashboard of our own flagsmith, one of our own flagsmith project looks like. Uh, it can be messy. And really, the way to go, if you're a release manager, if you are the person in the organization who's responsible to manage this flag program, start asking a few questions, 3 questions. So the first question we want to find out is it stale? Meaning, when was the last time that the configuration of this flag has changed? This gives us a good indication about where this flag is in our delivery pipeline. We're basically saying a flag that has been on in production for 100% for over a certain amount of time, we call that a stale flag. So that's something we want to look into. A second thing a release manager we want to understand about every single flag is it in the code? So one thing is having your flag defined in your flag platform. The other side is this flag actually in the code? Is it being evaluated anywhere? That means going to the code. That means searching for it in the code base. Many times that's not so simple, but this requires us to step out of our flag dashboard and start looking in code. And the third question to ask ourselves is this flag still being evaluated? So is anyone actually using this flag? Is anything calling this flag? Does this flag ever give a different response? Does it give any response? Is anything calling it at all? And we need to ask these questions in order to understand what is the real status of this flag now. And although it might seem simple, in practice, this data can conflict. And that's when it gets really tricky. And we can give an example, a real scenario. You could find in your program a flag that's been stale for 30 days. It's on in production. Nobody changed the configuration for over a month. And you search for it in the code and you can't find it. It has no references in your code base. But then you look at the analytics and you see that it's still being evaluated. So sounds impossible, but this is actually very possible. And one of the likely reasons this is happening is because you have users who might be running an older version of your application. So maybe in the newest version of the app that you released, this code doesn't exist anymore. But not all of your users upgraded their application to the newest version. So the version they're running actually still evaluates this. It can also be a ghost in your system. We found a few ghosts. That happens as well. Becomes very tricky to understand. But once we ask ourselves these 3 questions, we can at least start to understand where we're standing. And there's a big risk in making a wrong decision here. So flags can be mission critical, they can be infrastructure critical, application critical. Most importantly, these flags are business critical. As we see more and more code, again, this muscle of using flagging when you deliver, we're seeing code either safeguarding or protecting certain applications you might not want to expose yet, or maybe you've used flags to switch your payment providers. There is a lot of business value hiding behind every one of those flags. And the thing is, we don't always know exactly what it is. We can't be certain. And then it even compounds. So we can have dependent flags. Some flags are getting other flags. We see this pattern with some of our customers, and that's not outrageous way to build your flags. It makes sense sometimes that you want to create flags that are dependent on others. It just complicates the situation way more when you try to decide what's the status of a real flag. And everything we described is just one flag. So going back to hundreds, if not thousands of flags, this is a lot of work. And this volume of flags really adds up very fast. It's not fun. No one wants to make a mistake here. No one wants to get blamed for removing a mission critical flag. And that's really one of the big reasons why we see over and over these flags just stay there. And this is exactly the kind of ambiguity that we build the tools to resolve. The flag lifecycle assessment is actually very simple. 3 questions, 4 actions. We cover the questions. Is it stale? Is it in the code? Is it being evaluated? That's the base of the framework. From those questions, we can come to 4 different possible actions. One is keep. If we see that the flag is being evaluated, it's performing what it was intended to do, we leave it alone. When we get mixed signals, when they conflict, this is where a human needs to step in. There are judgment calls to be made, there is business knowledge behind things. The decision cannot be made automatically just based on signal. So this requires more investigation. The third is deprecate. When the signals are clear, we can gain confidence that this flag is on its way out. It should go. And the best practice here is to mark it, to tag it, and lock it down for a certain time window before we remove it. It's just being a little bit extra safe, but we mark it as deprecated. We don't need to review it again. And after a certain time frame, it's ready to be removed. And the fourth action, when all of these are aligned, when we see that it's not in the code, it's not being evaluated, no one touched it, it's safe to remove, that's where we clean it up. Either archive it if you're using Flagsmith and you're using that option, or completely remove it from your Flag program. So it's actually very simple to make order out of this chaos. We ask ourselves these 3 questions. And based on those, we determine what's the next action from these 4 options. But that's a lot of work. As we mentioned, this takes time, and this is just one flag. And if you want to do this to clean up hundreds, if not thousands, that accumulates very fast. And that's why we have some tools at Flagsmith that help you do exactly that and automate a lot of the steps in each one of those gates. I won't cover all of them, but a few critical ones for this is the stale flags feature. So this is configurable by you. The default and what we're seeing is most used by customers is 30 days. So we can define in our application that we define stale as 30 days of no change. If you're more comfortable with less or more, that's up to you, and it really depends on your release cadence and how you treat your program. But 30 days is usually a pretty safe bet there. Whenever you don't change a flag for 30 days, automatically our system will flag it as stale, and you'll be able to see that. The second one is code references. So instead of you needing to go to your GitHub repo, search for the name of the flag, try to understand what it actually does, if anything, if this call is, we have code references. The way it works is that it's installed on your GitHub repo. It runs a nightly scan, and it only communicates back to Flagsmith about the exact reference where a flag is implemented. So we don't get to see your code under any circumstance. The only thing that comes back is really the flag and the file and line number where this flag is implemented. And that gets attached to the flag itself. So then it becomes way easier when you're looking at the flag to understand, is it used in my code anywhere at all? The third one is flag usage analytics. Every flag that evaluates traffic records an analytics event. This is accessible both in the UI and via the API. And that's the best way to answer the question, is it actually being used? So it could be stale. Maybe we're not seeing it in the code anymore. But if we're seeing this flag is still being evaluated, we should be extra cautious because that means that something, somewhere, somehow is still sending traffic to evaluate this specific flag. And we need to dig deeper to understand. A few other tools that help are Feature Help. Feature Help connects to your observability platform. It can be Grafana, and it catches related alerts. So if a certain flag triggers certain alerts, That's something that we use the webhooks to send back into Flagsmith. It surfaces on the flag level. And although this is not directly related, this is a good indication. If you have the practice of attaching flags to certain alerts and you're not seeing these alerts, that's an extra point for a flag that's safer to remove. Two other features that help us understand this is version history. So when we look at a certain flag, we can see, for example, the entire history of changes. A flag that went from completely disabled to enabled in dev and then enabled in prod to 50% and then rolled out to 100% in prod, and that's it. That's a one story. Sometimes we see other flags. We can see a flag that went back and forth in production. It was released 5%, reverted back. A few days later, released again to 10%, went to 20, reverted back. This is not uncommon for flags that release new functionality that may trigger unintended functionality in the system. When we see a flag that went back and forth like that, that's another point for us to be a little bit extra cautious before we go ahead and remove it. And the third is the built-in governance that's just covering the entire Flagsmith application, full access control, audit logs, RBAC, approval workflows, all of these features that we have in place in order to help you understand when you look at a flag, what exactly happened, who did what and when, and get a full tracing of events that led the flag to where it is today. But the real answer is not to sit and do that manually. Even if you use these tools that we mentioned, that's still a lot of work. And a way to automate that is to use the MCP server. So an MCP server, that's a wrapper of an API that is being used by LLMs. It makes requests, it processes results directly, and it's basically what allows your Claude or GPT or whatever you're using to use Flagsmith without you needing to drive every single query. Humans have open API schemas, LLMs have MCP servers. They serve the same need to help us understand how to use an API. And the good thing is that AI is actually really good at crunching through thousands of flags or any amount of data repeatedly, and it really doesn't mind doing it all day, every day. A task that's for us not fun and time wasting is a prime example of a task that we can delegate to an AI. It's automatic, it's pedantic, and it's basically a release manager that just works around the clock. So a very simplified example of that would be a prompt telling your AI, your LLM, show me all the flags we have in production that we haven't touched for 90 days, have no code references, but are still receiving traffic. The response could be, here are 7 flags matching those criteria. And really, the benefit of using an MCP server versus building your own API integration is that it has a structured interface. It's composable. We maintain it instead of you needing to keep it up to date. And it evolves with our platform as our platform evolves. I'll put this into a bit of a practice here, an example. And this is an oversimplified example, but I went over to Claude. In this case, it's Claude Desktop, not even Claude Code, and just asked it first to list all of our flags using the API, using the MCP server. So it found the organization, the project we're in, found the first 100, iterated to get the full 120. And then it found we have 48 active flags. I'm just going to pick one to continue here. One of the checkouts, checkout V2. This is a multivariant checkout, multivariate flag, design B, design C. Okay. Whole bunch of flags being surfaced here. And these are just the active one. In addition to those, we have 72 archived flagged as well. And Claude itself was a bit shocked, saying that's quite a bit of flag debt in the archival pile. So this is already beginning to be frightening for Claude itself, looking at these numbers, and asked if they want to dig into any of those. And my instructions here were again very, very simplistic, just demonstrating how these three tools can really work. Yeah, it's a mess. Let's look at the active ones and find the ones that are stale, that have no code reference, and are not getting any evaluation. So really the three questions, the three actions that I would do myself if I wanted to start cleaning this up. So Claude got to work. This requires quite a few API calls that were orchestrated directly by Claude to make this happen. First, it found the flags, then it led to searching for evaluation data using the responses from the previous queries. So it was actually able to find the stale flags. And then once it got the full picture, it identified top 5 deprecation candidates for us. So those have zero co-references, zero evaluation tracking, and have been stale, not modified for over 30 days. And one of those is our checkout experience, last modified in September. That's a while ago, almost 6 months that no one touched it. Zero code references, zero evaluations. And probably Claude is correct here. This looks like an abandoned A/B test. So here's another example where a name is pretty misleading. We called it V2. We expected this to be a new version. In fact, it was most probably an experiment. So naming convention probably failed us here. And that would be another reason for it not to jump up for us and find it. It also found a few flags such as maintenance mode, but it was smart enough to understand that this is most probably a permanent flag and not a stale flag that wants to be deleted, but something we want to keep. So this is really an example of how we use the MCP. No skills, no specific workflow, just 3 prompts asking it to go ahead, fetch all the flags, then go ahead, find the stale ones, file the ones with no code reference, and that have no traffic. And there is a spectrum for this automation, and you can really choose where you want to stand in it. So not everyone is totally comfortable with using LLMs to their full extent and power these days, and that's fine. I am personally somewhere in the middle here. But when we look at the different options of how we can use the MCP server, the power of AI, leveraging all of the features we mentioned in order to try to make order in this chaos, we can see 3 different points on this spectrum. So one is that the human drives. You prompt your LLM to fetch all the flags, you review the results yourself, you make every call. This already works very simply with Claude Code, Claude Desktop, any MCP supported interface. Level up, and we can look at the schedule digest. So we can trigger from Claude Cowork, or if you're using any other AI automation, we can trigger a daily, a weekly cron job prompt that basically does all of this behind the scenes, and the results can be sent as an email, as a Slack message, and just tell us, hey, I found 3 stale flags, no code references, here are the links. So this is a more proactive approach. It doesn't need a human to initiate the process, but it still defines a very clear boundary between what the AI is responsible for and what the human is responsible for, and where does the AI stop. If you want to go to the end of the spectrum, AI drives. So it's totally possible, and we've seen this happen already with some of our customers. LLM does the whole thing. It fetches, it triages, it integrates with other MCP servers, so it has access to the code if needed. It alone decides the fate. And if you're ready for it, it can open a PR to clean up the code if needed, as well as directly use the MCP to remove and delete or archive a flag inside Flagsmith. So this is a fully automatic approach. My personal recommendation, start on the left, get comfortable, find what works for you. Sometimes these prompts need a little bit of adjustments to your specific use case. You might have naming conventions in your flags that help you identify what is the prime candidate for deprecation, what is not. And as you gain confidence using the MCP server and AI in general, you slowly shift towards the right, ultimately to a place where AI does the vast majority of the heavy lifting of keeping the flag lifecycle in a clean order. So going back, this is really a good problem to have. Having lots of flags is a strong indication of a healthy engineering department, of a healthy release process. It's a good thing to find yourself with many flags. That in itself is not an indication of doing anything wrong or not using flags correctly. It helps to release more safely. It does increase your velocity, and it does show a mature development mindset that really doesn't go away. There's just a tipping point. At some point, this complexity really becomes real, whether it's because AI is shipping more code directly, the engineers are using AI to leverage their own work. Just the sheer number of flags is increasing. And the solution is really tractable. So stale detection, code references, usage analytics, even data from other MCP servers that you can pull in, this really does give you everything that you need in order to make a confident decision, even at that scale. 1,000, 5,000 flags, that's intimidating for any PM and any engineer to go and even start looking at that pile. It's not intimidating for an LLM to start crunching through this. You can split those up, start with 5 a day. It will take some time, but you don't need to look at that pile of flags and not even know where to start. So we did mention quite a few tools. There are more to come. Um, we're offering soon a self-hosted MCP that can support air-gapped environments and any instances behind VPNs. We are working on a fully dedicated lifecycle management dashboard that will help surface this even more. Integration with additional code repos. We've got GitLab right now as our prime candidate, and we're working on pre-built skills for quick setup. So skills for the MCP server. We encourage you as well to build your own skills. What we showed as 3 prompts can very easily be turned into a flag lifecycle management or release manager skill that is tailored to the way you work, to the way you release. And it makes using the MCP even easier if you have it pre-built as a skill that can be run by anyone, engineers, products, release manager. That means anyone can follow your own structured best practice in order to run a cleanup session for your flag program. So really well done. If you found yourself having this problem, congratulations. You're doing a great job. You're adopting flags, you're releasing more, and you're doing that in a safe way. We've seen that this is becoming a bigger issue as you progress. And that's when attention needs to start being put back into how do we now clean this up? What can we do to make this more manageable? So if you're ready to clean your gutters automatically, Flagsmith users right now, the MCP server is available. You can go ahead, connect it. Within 10 minutes, you can run your first audit. It's really as simple as that. If you're not yet a Flagsmith user, it's almost as simple. We're open source, easy to set up. Add 10 minutes to those first 10 minutes of audit just to get it up and running. And you can really start to experience what it's like working with us for managing your flags and more so for keeping your flag program in control. As I mentioned, starting from human in the loop gives you the most confidence about using these tools. Get comfortable with the data, slowly automate as you go. And finishing with Mr. Einstein quote, out of clutter, find simplicity, one of the 3 rules of work. Uh, it looks daunting. It can be scary to try to understand what's going on. It just feels like one big mess. Three questions, four actions. That's the simple framework that you can take from here and implement on your own. It might take a little bit to get those hundreds or thousands of flags under control, but following this very simple framework will really lead you from clutter to simplicity.
Thank you,
And
Asaf. I saw a number of really interesting questions coming in, so I think what I'll do is read them out to you and we can go through that. And if folks haven't sent their questions through, please do so now. We have a few more minutes to go through those. So the first one that came through was, how does this compare to your example with Uber's Piranha or doing it yourselves?
sure. So actually, Uber Piranha was only code cleanup. So it was not integrated with the feature flag software application itself. It was something they built just to try to identify in the code what can be deleted. And when you compare that to the MCP approach, that's a full life cycle. So not only looking at your code and your code references, but it connects to Flagsmith all the way to marking flags as archived or even automatically deleting them. So that tool was cool for identifying places in code. Um, I think I remember seeing a result was 70,000 lines of code were removed from the Uber application after they ran the tool that they built, Piranha, and were to clean up their code. Yeah, so that's meaningful. That's a lot of code.
Wow. Yes, it absolutely is. Okay, and what about flags that should be permanent?
Yeah, good question. So you can define in Flagsmith, you can define flags as permanent flags. We use tagging for that. There is definitely a use case for permanent flags. Uh, Many different kinds. Some are kill switches, some are switching between third-party services that you're using. We're seeing all kinds of implementations of flags that are intended to be permanent. Mark them as such. That's the easy solution. You can define in Flagsmith what tags are considered to be permanent flags. So you can really build your own framework there. And when you do that, it's very easy later for your MCP, for your skill, for whoever's using it to understand that this flag is marked as permanent. Therefore, I'm not even going to consider it as a candidate for deprecation. So you can use that tool to exclude those from the program.
Okay. And so the flag lifecycle management tool via AI sounds straightforward to implement via a script hitting the Flagsmith API that runs as a cron job. What does the MCP server approach offer over that approach?
Yeah, you can implement that yourself. I mean, even without an MCP server, one of the great things about Flagsmith is that we are truly API first. Anything that can be done through the UI can be done via the API. If you want to write your own code and maintain that, that's one way to go. The real benefit of using an MCP is that one, you have the option to integrate your workflow with additional MCP servers. So if you are going to open a PR to remove a flag from code, so that's an MCP server that Claude or whatever you're using already has, you can use that. If you want to check data from Stripe, from HubSpot, from your analytics platform, all of these third-party services have MCP servers. So you can ask bigger questions as part of this cleanup flow, and you can get more data about what's really going on. So from my perspective, that's a big plus. And from an engineering perspective, we manage it, we release it, it gets upgraded when we upgrade our API. That's one less script that you need to write yourself and keep updated yourself. So we just do it for you. It's much easier.
Excellent. And I think we've got one more question that I'll make the last one. And please, if your question didn't get answered, feel free to follow up with us via email. You can just respond to the invite that you sent me or via our website. Talk to us there. Last question. The code references sounded really interesting, but it looks like it doesn't support GitLab or Bitbucket right now. Is that something you're planning on changing?
True and absolutely. I don't know, I can't see who this question comes from. And if you're a Flagsmith user, we are working right now on expanding our support for code references for GitLab. That's the first thing that's actively being worked on. We are looking for next repositories as well. Whoever it was that asked it is invited to reach out. If you're using Flagsmith and GitLab, please get in touch. I would love for you to be part of testing this out as we release the first version and making sure that it works for you as well. But yes, we are actively working on that.
Excellent. And with that, I can see we're just at the end here. So thank you really everyone for joining us. A reminder that we will be sending out the slides and recording to everybody who joined today. And please do feel free to follow up with any questions that you may have, anything you'd like to discuss. But thank you for giving us your time today. And thank you, Asaf.
Thank you, Mia. Thanks, everyone.
Perfect. Thank you. Bye.